Hi and welcome! Today we are going to create a typewriter for TextMesh Pro. This is how it will look and behave. We wanted to control the writing speed, how long to wait after an interpunctuation, be able to speed up or skip the writing of text entirely, invoke an event on every letter to hook up our typewriter to other systems, and lastly, have an event invoked once we reach the end of our text box. Furthermore, we don't want to append letters one by one, but instead control the effect with TextMesh Pro's maxVisibleCharacters to lessen the load on our system. And lastly, this typewriter is doing its thing automatically whenever the content of our text box changes. Thus, at the end of this tutorial, we will be rewriting a couple of lines of code to turn the prototype into the main thing. This can all live in a single script which will sit on the game object with the TextMesh Pro component. Let's create a script and call it Typewriter Effect. It will have a required component of the type TMP_text. To be able to test our whole system, we will also add a test text string to our typewriter. This is just for prototyping the system. The finished typewriter will be set up in a way to handle strings from outside. We will start with the basics, displaying a string one character at a time and having it delay the writing of the next character if the current character is some kind of interpunctuation. To accomplish this, we need a couple private references at the top, one for our text box and one for our currently visible character index. The script is going to rely heavily on a coroutine, so we are going to run into several different kinds of wait for seconds, as well as into the situation of wanting to stop our coroutine. I'm not a big fan of creating a new wait for second every time we'll be writing a new character, so I'll add a couple pre-made wait for seconds up here and set their values in awake in a moment. Also, to be able to stop our running coroutine, we will have it stored in a reference. To control the speed of our typewriter, we'll add characters per second, and to have it wait a moment longer on interpunctuation, we will need this delay. In awake, we'll get component the TMP text and set up our delays in a way that corresponds to our chosen values. To change the displayed text of our text box, we'll create a function called setText, which takes a string parameter. We'll set the text to our text box and we'll set the maxVisibleCharacters to 0. This value is important. If we were to append letter after letter, we would do a lot of string manipulation, which is notorious for being computationally expensive, which in turn means slower performance of our game. By using maxVisibleCharacters, we won't be running into this kind of trouble. We created a current visible character index at the top of our script, and here we'll need to set it to 0. If we don't, our value would stay at whatever the first maximum value will become when revealing our text, which would mean that future texts wouldn't work correctly with the typewriter effect. To be able to control the typewriter, we'll create an IE numerator, call it typewriter, and save a reference to it. We need to do this to be able to stop it if needed. This done, we will want to make sure there's always only one typewriter coroutine running. If we don't, we might run into some strange behavior. Onwards to our core system, the typewriter. First, we need a reference to our text box's text info, since there are a couple of important values to be found in there. Next up is a while loop that runs while our current visibly character index is less than the character count of our text box. We are going to need to get the currently to be displayed character and check if it is some kind of interpunctuation. We will need to get it like this instead of checking the textbox.text value, because our text could include tags. These are not being displayed, but they will count towards the characters in a text. We will reveal the next character to be displayed by incrementing the maxVisibleCharacter value. If our character is some kind of interpunctuation, we will yield return our interpunctuation delay. If it's not, we will only wait the normal amount of time. And lastly, we'll increment our currently visible character index. Let's check if our typewriter behaves as expected before extending it. Alright, looks good so far. Next up is the option to skip text. We can offer two ways of skipping: speeding up the writing or skipping straight to the end of the text box. We will need to add a private bool that is going to control if we are currently skipping, a new wait for seconds for the sped up writing of characters, as well as a bool to set depending on which style of skipping we prefer. Lastly, we'll need to be able to set a value by how much our skipping will speed up the writing. We'll need to add our skip delay to awake now too, of course. Somehow, our script needs to know if the player sent a signal to skip. In the old system, we can check it like this. In the new system, I tend to do it like this. Have an input action for right mouse button click, add a player controller to the text box and set it up correctly. As you can see here, you can now use on right mouse click in scripts on this game object. Back in our script, we can thus alert our script like this. This is not an input system tutorial, so this might not be the way to go. I recommend you go watch the linked tutorial on Pitty's channel to learn more about how to set this up correctly. Our skip function sets currently skipping to true and checks if we are doing a quick skip. That's the one that jumps to the end of the text box. If we are not, we'll start another coroutine that waits until all of the text has been revealed and sets the currently skipping back to false. But if we do skip to the end of the text box instead, we'll need to stop the Typewriter Coroutine and set the amount of visible characters to this. Now our text will just pop up when triggered. In our typewriter, to make sure we won't be running into any delays when an interpunctuation has been found, we will make sure to only trigger the search for them if we are not currently skipping. In the else part, we will change the yield return of a simple delay. If we are skipping, we want to return the skip delay. If we are not, we will use the simple delay. This line of code is a short version of this code. You can use either one. So, next milestone done. Let's check our results. I hope yours looks like expected too. If you'd like to have a look at the complete code, I have that in my GitHub repository linked in the video's description. Next, we want to be able to notice other systems on the stuff happening in our text box. This could be an audio player playing vocalizations or a next button being displayed once the text box is full. Luckily, this is probably the easiest part of this whole script. At the top, we will create events based on what we want to be able to notice other scripts about, and a float for the waiting time before the complete text revealed is being invoked. That gets used as a value for a new wait for seconds in awake 2. The first time we will be invoking the complete text revealed is at the bottom of our skip function once our text is being revealed. And since we are skipping, we won't be able to wait any amount of time before invoking it. The second time is located in our Typewriter Coroutine. We will get the latest character count of our text info. If our currently visible character index is equal to the last character index, we will wait for the duration of our event delay, invoke the event, and yield break out of the coroutine. The character revealed event gets invoked right before we increment the index. By handing it the current character, we can have other systems react to it. For example, play a sound only on question marks or certain letters of the alphabet. But that's a task of a different system to sort out. I have a small button I want to display when the text box is filled. The script for it looks like this and sits on the book element in my hierarchy. Onwards to the last part, our prototyped string we created at the top of our script. By now, we implemented writing, delaying, skipping and events, so let's finally get rid of the prototypey parts. This means we will delete the string at the top and add a new private bool ready for new text to the basic functionality. It needs to be set to true by default. More on that in a moment. To have the script work in the background, we will subscribe to TMP-Pro Event Manager's TextChangedEvent like this in awake and unsubscribe from it in onDisable. This event gets called whenever there is any change in our text box happening, and yes, this includes revealing letters. As you can see, we can't use the setText function now because we are using a string parameter for it. Let's delete the parameter and the line about setting our text box's text to the value, and replace the parameter with an object. Now we can properly subscribe and unsubscribe. Because this function will now be called every time something in our text box changes, it means that we won't get far into our text before the typewriter is being stopped and started anew. This is where the newly created Ready for New Text comes into play. If we are not ready, we will return and not interfere with the writing in any way. If we do get past the check, we'll need to set the ready to false to make sure our text is being displayed as planned. Because we are not setting the text anymore, let's also rename the function to prepare for new text. And since we are not setting anything by hand now anymore anyway, let's also get rid of the start method entirely. In our typewriter, the only addition we need to make is once our text is done being displayed, we set ready for next text to true once more, because it's likely our text to be displayed changes around that time. Do not forget to add it to the skip function as well. So, last check. Does it work? I hope you enjoyed this tutorial. If you did, please give it a like and subscribe if you haven't done so already. It would make my day. You can find the scripts in the linked GitHub repository below. Have a great week and see you next time.